Here we are in section 7-2, exercises 31 through 39. We're told to rationalize the denominators. Rational means turn them into a normal fraction. Irrational numbers are square roots that don't come out nice. So we're supposed to make sure that the denominators, we're timesing top and bottom by something that allows this to be a rational number. Perfect squares come out of square roots. Perfect fourths come out of fourth roots. Perfect fifths come out of fifth roots. Okay, so let's do it. Since we have a fraction, we get to multiply top and bottom by anything we want. So we can times by, well, what do we need here? We need a perfect square. We already have 113, so let's times by another square root of 13. And we get 4 square roots of 13. The top doesn't look very nice, but on the bottom we get square root of 13 times square root of 13, which is square root of 169, which is 13. Look at how happy that is. Square root of 13 times square root of 13 is 13. Now that doesn't look more simplified, but the denominator has been turned into a rational number. And that was the instruction, is to have enough ability with irrational numbers to make the denominator rational. And that's considered simplified. So here, yeah, we have a 6 under there. Let's times by square root of 6, square root of 6. And we get 4 times the square root of 6 over square root of 6 times square root of 6 is indeed 6. In slow motion, it looks like this. Square root of 36, which is a 6. Ooh, but that simplifies. Look at that. That 4 over the 6, 4 and 6 both have a 2 in them. So this becomes 2 square roots of 6 over 3. Have to simplify that by taking a 2 out of the top and the bottom. All right, the next one. We don't need to worry about that 6 part. We just need to take care of the square root of 5, square root of 5. So we get 5 square roots of 5 over 6 times 5. And can you see this? That 5 now cancels with that 5. 5 square roots of 5 over 30 simplifies to square root of 5 over 6. Yeah. Okay, number 34. Ooh, now notice this. This is a fourth root. If we were to times by the fourth root of y and the fourth root of y, we would get the fourth root of y squared. That doesn't solve anything. We need a perfect fourth. So we think about, if we can times by anything we want, there's one of them in here. We need 3 more. And what does that do? Down on the bottom, we would then have the fourth root of y times y cubed is y to the fourth. That's the key, making those two things exactly equal so that the fourth root of y to the fourth is indeed a y on the bottom. And this becomes sixth root of the fourth root of, not the sixth root, 6 times the fourth root of y cubed. That's where that answer comes from. We had to times by something to get this up to a perfect fourth. Good. So let's try the next one. This is a fifth root, so we need to times by something. I see fifth root of and fifth root of. We need to times by m to some power to make this up to a perfect fifth. Well, we already have 2 of them, so we need to multiply by 3 more. And look at the power that we have to pick that number. The one perfect number that allows us to do 7 times the fifth root of m cubed over, if we times these two together, we get the fifth root of m to the 5th power. Look at what we just created. Fifth root of m to the 5th is m, and it is no longer, certainly assuming that m is rational in and of itself. But yeah, that gives us that the m came out of the radical and is no longer irrational. All right, number 37. Sorry, number 36. We've got a times by. We need a perfect 7th in here, so we need 2 more. The 7th root of x squared. And that is the 7th root of x squared. So we get 11 7th roots of x squared over, in slow motion, this is the 7th root of x to the 5th times x squared gives us x to the 7th, becomes just an x. No unsimplified radical on the bottom. Love it. Number 37. We need a perfect cube under here, and we only have one t, so the cube root of t squared is what will get it to us. Cube root of t squared, and that will equal 8 cube roots of t squared all over, in slow motion, the cube root of t. Now t times t squared is t cubed. Those two things undo each other, cube root and cubing, and we get a t. Beautiful. Number 38 looks a little bit trickier here. Here we have the 4th root of 27. Now we could multiply top and bottom by the 4th root of 27 cubed and have a huge number here. But there's some simplification that can happen here first. Notice this. This is actually the 4th root of 3 to the 3rd power. This is already a perfect cube. We already have 3 3's in here. So really, we only need to times the top and bottom by 1 3. And that will make, in slow motion, when we times these together, we get the 4th root of, we get 3 to the 4th power. So yeah, that's the secret on this one, is that you recognize this is a perfect cube already. You're like, oh yeah, I already have 3 3's. I just need one more to make it a perfect 4th. 5 times the 4th root of 3 over 3, just like that. Yeah, 4th root of 3 to the 4th. Okay, last one, number 39. Okay, is this already a perfect square or perfect cube? Yes, it's either 8 squared, or we could also see it as 4 cubed. So we already have 3 4's. We just need one more of them. So we're going to times the top and bottom by the 4th root of 4. And times top and bottom by 4th root of 4. So we get 12 4th roots of 4 over this, in slow motion, 4th root of 4 to the 4th gives us just a 4. And 12 divided by 4 is a 3. 3 4th roots of 4. All done.